So hello and welcome to another Clojure Diary video. So in this video, I would like to explore what is probabilistic computing like, and I would like to explore it with Clojure, right? So that's the thing. And yeah, okay, what's my settings? Okay, right, okay. So this company Extropic, okay, look, of course, AI is consuming a lot of power, and we need gigawatts of power, and big giants want to construct uh, nuclear power plants besides so what to say this massive what to say graphical processing unit data centers and all those stuff. So that is just going on, and yeah, it consumes gigawatts of power and all those stuff, right? So and this company says like it can do the same AI stuff, the training stuff or whatever it is, like with 10,000 times less energy. So to give a perspective of it, a gigawatt means yeah, yes, okay. A gigawatt means, yeah, it's 10 raised to the power of 9, right? And if you divide it by 10,000, that's 10 raised to the power of 4. You'll get 10 raised to the power of 5. Okay, so that's the thing, right? So Uh, I don't know what I'm just getting. Okay, right. So, okay, right. So that's the thing. And actually, you should be getting. Okay, like I don't know what's really happening over here. Like, right? Didn't I specify the brackets properly? Right. Right. Yeah, I don't know why this is putting output like this, but yeah, you should get like 10 raised to the power of 4. So, okay, 10 raised to the power of 5. So that's round about like 1 followed by 5 zeros. So it's like 1, 2, 3, 4, 5. Okay, right. So this is very less. Okay, this is like 100 kilowatts or running 50 or what to say blenders at the same time, and maybe like yeah we can have very big AIs running even in laptops. I don't know whether the chips can be shrink to the size of laptops or whatever it is. And you're saying like okay, it's thermodynamic computing, right? So that's what they say. And yeah, I don't know exactly how they do, but they said a term called probabilistic computing, and I do know about it because yeah, I'm just doing AI and data science project for people, and I also explore it for fun, and so I just know what it is. So I'm just going to say what is probabilistic computing and how this extropic is might kind of do and all those stuff. Okay, and yeah, and the term they say is like they are doing thermodynamic computing. Okay, so just imagine let's say okay, like now I just need to launch my Ripple, right? So okay, yeah, let me just launch it. The reason why I'm just launching Ripple every time in my video is like, okay, like a person who might be new to Clojure should also be able to do something. Maybe he might not follow the whole video, but you should be able to do something, right? So that's the thing. So I'll just select this connector running Ripple, not in project. Okay, so and lead engine and yeah, this is how I launch my Ripple, right? So, and if you haven't noticed, I just put lean Ripple and whatever port number it came over here, I just gave it, and that's it. My Ripple is there, right? So that's how it is. Yeah. So, okay. So let's say okay, like this Anthropic. Okay, like I'll just put another private window, right? So, and put this excellent tool called Excalibur, right? Okay, so this Anthropic, they claim that okay, like they can set some bits, something like thermodynamic bits. So some bits are high and maybe like some bits are low, right? So maybe this one is positive and okay, so let put it as red and okay, that is like high and this let us put it as blue. Okay, so that's the thing. And somehow they are saying like okay, I don't know, okay, let's say this is high temperature, this is low temperature, whatever it is. Like yeah, I'm just making things up over here. So let's say like, okay, like I just want something 60% higher. I just want a number like 60% or something like that. So I can put something like this, 3 high temperature and, oops, all right. Okay, right. Okay. And this 2 low temperature, right? So, oops, okay. I don't know what happened to this tool. Yeah, like, uh, or is it something with me? I'm not sure. So like this is 60% high and or to say like 40% low, right? So totally this 5 thermodynamic bits or whatever, T bits or whatever, let's call it as T bits, okay, right? So that's the thing, right? And this I think they can generate it very efficiently. Okay, so it's just like this Clojure function, like rand binary. Okay, so if I execute this one, right? Okay, so and if I say like rand binary, and if I just say like, okay, I just want 5 bits and the temperature is zero point 0.6, that is 60%. Okay, so, and I'll just get something like this one. Okay, so yeah, of course, the next time I might get something different, right? So next time I might get something different, right? So that's the thing. And so, yeah. So this, they are able to do it with a lot of bits. Okay, right? And with this, we can do some computing operations. Okay, and yeah, and we can do something like what to say, we can develop something like a neural network or something like that. Okay. So I'll just tell you how. Like, let's say like there is a neural network and there is a input you're just giving to it. So let's say like it's 0.3 and over here it needs to be multiplied with 0.7. Okay, right? So 0.7, right? So how to do this with probabilistic computing? Okay, right? So now you just need to set something, okay, like what to say, like this rand binary, and let's say, okay, let's keep it as 10 bits. Okay, so at 10 bits, and then let's put it 0.3, and then you get something, and next we'll just put like 0.7, and you get something. Okay, so that's how it is. So, right, okay, right. So now let me just assign it to, okay, right. So, um, okay, like how to do an AND operation, okay, right. Can I just give something like map and or something like that? Yeah, okay, so I just need to put this one, right. So map and this thing, right. So I will just do this map. Okay, sequence 1 and sequence 2. So this is the first sequence. Okay, so and this is the second sequence, right? Okay, so and I think I need to remove this off, right? Thanks to AI, it is auto completing everything. Okay, so right. Okay, so and right. So if I just do this, what is 7 into 70% into 30%? It's 21%. Okay, so and okay, like is it are we having only two trues over here? There is one over here. Okay, now it just says 10%, but yeah, this is very, very small number. Okay, but if you do it for very, very large number, we'll just get something different. Okay, so and 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 yeah, now we are just getting like 20% over here, like true and true. You might even get 30%, but if you take very large numbers, this is going to average out. So this is how you just do. And and okay, like okay, how you will multiply in traditional computers? Okay, like either you can have some kind of circuit, okay, like that takes us 0.7, 0.3, n bits for 0.3 and n bits for 0.7, and n bits as output, because the output is going to be always less than or equal to 1 if you're only going to compute from 0 to 1. Okay, so that can be done, but yeah, that might be complex. Okay, so complex. And so let me just put like, okay, this one and oops, uh, this one and this one, right? So that can be done, or you can have something like repeated uh, ALU, or a repeated addition or something like that, where okay, maybe you can multiply this by 10, okay, and multiply this by 7, so you'll just get it as 7 and 3, right? 7 and 3, and 7 and come on, 3. Now you just decrement this 3. Okay, this 3 will become 2 and the 7 will become 14, and that's how it is. Next, this 3 will become 1 and 7 will be, and this will, another 7 will get added, 21, and finally you just divide it by 100 because you divided, oops, you divided this point 7 is 7 by 10 and 3 is 3 by 10. Okay. So finally, you'll just get this answer. Yeah, this takes a little bit of time. Yeah, this might be complex and might even be energy intensive, but maybe this setting this T bits or thermodynamic bits or generating large amounts of them is very easy, and doing a simple AND operation on them. It's all just AND operation, right? So it's all AND operation, and it's very easy, right? Okay, so that's how it is. And maybe yeah, we need to do some summation. Summation is nothing but okay, like what to say, like okay, right. So that's also a bit easy. Like, okay, you just need 3 plus 5, right? Okay, so 3 plus 2, okay, right? So, okay, this is 3 out of this, and this is 2 out of this. Okay, like, okay, so 2 over here, and 3 is down like this. Okay, right? Oops. Why am this is happening? Okay, yeah. So all you just need to do is just count the temperature. Okay, so the high temperature, right? So maybe that is also easy, right? So this is how they are just doing. Okay, so I've just written a very simple thing, and okay, right? Okay, over here I've just got something like true count. Okay, a function called true count. Okay, so and oops, I don't know what happened, right? Ah, yeah, I didn't execute this true count. Okay, so yeah, true count. And if I just put true count of 1000, whatever that computational bits and 70%, okay, right? So I'm just getting it like 706, which is very, very close to 70%, right? Maybe I'll just run it on again 707. Okay, it's very consistent. Okay, right. So it should center around about like, okay, if you take maybe 10,000, it's really going to be near 70%. Or if you take like 100,000, it's really, really going to be near 70%. Okay. And then I've just got this, okay, this X, which is multiplication, right? So I didn't find a good name, so I just gave it X. Maybe I should say it multiplied. Okay. So multiply or something like that. So you just give it, okay, that I just showed it over here. You just take two sequence and you just give it, and it just maps and to it. So that's it. Okay. So, uh, okay, right. Okay. So in very, very efficient terms. Okay. Let me just close this window, right. So this also, what to say? Oops, where did I put my Excalibur stuff? Okay, right. Okay. So yeah. So this can just be AND gate, okay, AND gate or thermodynamic AND gate or whatever it is. So all it just does is, okay, if you just give, what to say, high temperature and high temperature bit, it just gives high temperature bit, and it all needs to be aggregated and finally counted. Okay, so and if it's greater than some count, just fire that neuron. Okay, so that's the thing. So maybe really, really efficient. So that's the thing. Okay, so and that's what happens over here, right? So, okay, like, okay, this I've just wrote it into REPL. Okay, like now let's load this small count. Okay, I'm just doing with 10 bits. Okay, so, and over here, small 70% is nothing but random binary and the small count. That is, we just need this 10 T bits or whatever it is, and 70%. Okay, its temperature is 70%. Okay, so that's the thing. That's why I've just named it as temp. Okay, right. So 70% of it will be high, and yeah, so this should be like somewhat like 77 out of 10 is should be true. Okay, like somewhat. Look, this is all statistical computing. When that's enough for neural network. You don't need to be really, really accurate. Like you're not doing some high precision machinery or something like that, or CNC or something like that. It's okay. Like it's just like you driving or throwing a paper ball into the trash or something like that. It need not be accurate. All it just needs to do is to go into the trash. Or whenever you just drive, if somebody comes from the left, you just steer away from left, or if somebody comes from right, you just steer away from right. So it's not so accurate. You don't do it with millimeter precision or something like that. So that's enough for neural network and all those stuff. So that's the thing, and that's what we are just doing over here. And yeah, like and yeah, of course, this true count. Okay, small 70%. Okay, small 70%. Why it's only 3, right? Rand binary, small 70%. Okay, right. Okay, this is small 70%, right? So how much truths here? One, two, three. Uh, how can this be? That can't be true. Small 70%, right? 1, 2, 3, 4, 5, 6. Yeah, I think only now I'm just getting the right number. I don't know what happened over here, right? Okay, so now it's just 7. Okay, it's bang on target 7. Okay, so and small 30%. Okay, right? So and I'm just printing it out here. So finally, it's just anding stuff. Okay, so and okay, like over here, this true count and it's 5. Okay, okay, that's okay. Look, it should be 3 out of 10, but yeah, 5 is okay, right? For small numbers. Okay, right? Okay. And now what you're just doing is we are just multiplying like small 70% and small 30%. And this should be around about like 2 to 3 or something like that. But over here it's still 4 because 5 and 7. Okay. Look, this is just random stuff. Okay, right? The thing is like you are able to set the right temperature and you are able to set the temperature, and for large enough values it should be very accurate. So for true count it's not going to be so accurate. Okay, like zero point 0.7 into zero point 0.3 should be 0.21, so it should be like zero point 0.2 or 2 out of 10. Over here we are just getting 4 out of 10. Okay, so that's not so good, but yeah, that's okay, right? Now we'll just do it for large count. So this is going to be really around about 200 or something like that. Okay, so 200 out of 1000. Okay, so large count, and then over here 70% is whatever it is. Look, I'm not displaying because I don't want to display 1000 stuff. Okay, right? And 30% is this thing, and true count 70% is 701. Okay, bang, almost bang on target. And this is 3 to 4, and true count of multiplication of these two stuff is 239. It should be 210, but 239 is okay, right? Okay, so the larger and larger you go, it's going to be what to say, like highly accurate and something like that. And look, this divided by 1000 is 0.23, which is near 0.21, which is the right number. So now I've just put like 10,000, right? So that's the thing. And 70% and 30% and true count of this is okay, like very accurate to 70%. Okay, almost 70%, right? And this is almost bang 30%, and this one should be 2-1 something like that. Yeah, so the more you do it, the more what to say, this probability bits or this t bits or thermodynamic bits you have, the more accurate you're going to get. And you can do very simple, and you can do multiplication or something like that in this very simple way. But of course, like saying is highly simple. Like maybe this Extropic is doing something really great which others are not able to do, and all those stuff, and that's the thing. But what they are doing is probabilistic computing, and this is what I understand about probabilistic computing. And look, I could be wrong, I could be totally wrong, and this is my idea. And I just thought, okay, why not simulate in Clojure? And because Clojure seems to be very excellent. With other programming languages, I need to type a lot. Okay, so and yeah, I just need to find out why my program is putting something out like this, and that's very what to say, like I never expected this one, right? Okay, I just expected a number, right? So that's the thing. Okay, right, of course this program is written by me. If you want, you can download it from this link. Okay, so yeah, so so that's what is probabilistic computing, and I'm happy to tell what I understood about it from using Clojure. And of course Clojure is my favorite programming language right now, and that's about it, right? Anyway, thanks for watching. Until we meet in next video. Bye.